Hello! Today is sports day, but that doesn't mean we can't continue to learn about ASA congruence postulate and AAS congruence theorem. ASA congruence postulate basically states that if we have one pair of congruent angles and another pair of congruent angles, and the key term that we have to focus on is that this side has to be sandwiched in between the two angles, just like when we're looking at SAS. Remember how the angle has to be the one that's sandwiched between the two congruent sides? Similarly, in this case, our side has to be sandwiched. Now, as much as I love using that word to describe ASA, it's not exactly the most sophisticated way of saying it. And so we have to remember that when we're dealing with ASA, this side that's in that's in between the two angles is called included side. AAS is actually quite similar, but this time instead of looking at a postulate, we're looking at a theorem. So that tells us something, right? So with AAS, if we have, let's say, a pair of congruent angles, and then we have another pair of congruent angles, but this time we're not looking at this side that's included, but this has to be not included or non-included side. So let's imagine we have this fixed segment here, and we know that this has to be, I don't know, like 7 centimeters, right? Because if we're looking at ASA postulate, we know that we're given a segment or the length of a side. And now let's imagine we're also given this angle, okay? We also know this guy, this angle. I'm going to place it right here. Now, if this is what we have, is it possible for us to form a triangle using the two angles and then this line? We don't have to prove this because we know that once the included side is given with the two angles, we can easily formulate a triangle. But what about in the case of AAS then? So let's see if we can prove AAS together. We're gonna do a different kind of proof today. We're gonna be using flow proof. Now, what I like about a flow proof is that it shows the flow of your logical reasoning and steps. So let's imagine
I'm going to draw two triangles. I'm drawing two obtuse triangles, like so. E, D, C. It's a little bit shriveled up triangles, but let's, this will do for now. So we're given A is congruent to D, C is congruent to F, BC is congruent to EF. And we have to prove ABC is congruent to DEF. Okay, so this is how we write our flowchart. First things first, we're going to put all of our, I'm going to use some color here because it's getting depressing. I'm going to put all of our given information. We are given 3 different information, so I'm going to put all of them like so.
And then we're going to write our, we're going to write our reasons underneath. So this is given, given, given. Okay. Now, I think what we have to keep in mind is that first things first, if we're looking at our diagram, since we know that A and D are given, and we know that C and F are also congruent, that automatically tells us that B and E must be congruent, right? So knowing these two information, we can say B is congruent to E. And why? Because of the third angle theorem. We covered this quite a couple of lessons back. And then if we think about it, so that means now we know that B and E are congruent. So if we take a look, we can now use the angle B, the angle BE, as well as C and F, and also the included side. Now BC and EF end up becoming our included sides, correct? So now, next, we can use this, our side, and this, and maybe C and F. Yeah, all of those can tell us that ABC is congruent to DEF because we're using angle, side, angle, angle, side, angle, ASA congruence postulate, right? So that means AAS theorem stems from ASA congruence postulate, okay? So we just proved ASA congruence theorem right over here.
All right, so let's write another flow proof. So this time we're going to be looking at a triangle like this, and CE is perpendicular to DE. CAB is congruent to CAD, and prove ABE to ADE. So, let's first start out with our given information. That's given, and what else is, that's all that is given, right? Besides the fact that, well, we also know that, okay. So, because CAB is congruent to CAD, right? And we know that CE and BD are perpendicular. This is a straight line, which means BAB and CAB are supplementary, and CAD and DAE are supplementary. So, let's first start out that because CE and BD are perpendicular, we know that measurement of AEB is equal to measurement of AED, which is 90 degrees, and that's because of definition of perpendicular lines. right? And from then on, which means, hi. Oh, thank you, very tiny. Thank you. All right. So we know that AAB, AED, could say definition of congruent angles. But also, all right angles are congruent. Right? Okay, so when you gotta prove ABE and ADE. So we know about this one. And supplementary to CAB, supplementary to DAE, and that's because of linear pair postulate, right? When we have linear angles, then they're also supplementary. Linear pair postulate. And so we have this angle, so now we just have to know this right here, and we know that AE is just AE from reflexive property of congruence. So combining this and that, right? Puke, and puke. We know that ABA is congruent to ADE, which is ASA congruence postulate. Ta-da! So this is how we make a flow chart. Flow proof.